So, Vanakkam. So, we will continue our lecture on engineering seismology. So, I don't know how many of you are aware that so there was a earthquake, okay, in between the Bhuj and then the Pakistan, okay, then Gujarat, okay, the Bhuj region of the magnitude of 5 plus with a focal depth of 10 kilometer. So, this earthquake was reported in the USGS website. So, it has been given a yellow warning, not a green. Okay, so as I told you that if the magnitude of 5 okay, occurs in US or any developed countries like Japan and other place, okay, so that is actually nowhere related, but the same magnitude of 5 is occurred in India, which is equal to the effect in the 6 magnitude in Japan and US kind of thing. So, okay, so this was one of the news generally, I mean before we are ending our courses. So, this magnitude happened. I don't know how many of you felt or reported on this date. Okay, so where the yesterday this basically, okay, the 14th. So, June 2020. So, there was a 5 plus magnitude. Okay, so exact magnitude they are telling 5.1 to 5.4. I am not very sure. I didn't see the Indian meteorological data, but USGS it was announced actually. Okay, so we have been discussing about the prediction of the seismic hazard values, okay, estimation of the seismic hazard values. So, we have seen that the estimation of seismic hazard values, one has to know what is the maximum expected magnitude, what is the minimum, okay, distance it can occur, and then what is the recurrence relation based on the past seismicity data. So, these things we have discussed. So, how these parameters going to the your hazard estimation. Basically, the hazard estimation is done using the predictive models, okay, or predictive equations. So, today class we are going to discuss about what are the different predictive equations are available, particularly on Indian scenario. As on now, I try to make effort basically to going through different research paper and try to summarize those equations as part of my course. Okay, so, but this equation as on today, and also you need to verify the original papers, okay, you should not take it from the course directly, you should verify a original paper if you want to use that equation and estimate hazard values. Only I am giving you the summary, okay, so it is not a main reference, so you should check a original paper. Some of the equation even developed by my own team also, but still you should go to the respective paper rather than looking at our PPT. Our PPT will give you the information about the what are the different equation we are having, okay, as on today. Okay, so this may be keep updated frequently, depends upon the period, okay, and the data value. As we have seen that the predictive equation is the function of, okay, so the m, so which we have seen that the maximum magnitude m, and then the r. So, r is your hypocentral distance. So, remaining are the source parameters, side parameters and error term. So, these are all the major component. So, generally the m and r is a major contribution factor. So, source and site is, if you know the well defined source type like the normal fault, reverse fault, thrust fault, transfer fault. Site means soil site, rock site, okay, soft soil, medium soil, hard soil. So, all those information will be incorporated in the GMPs. Okay. So, that is called as a ground motion prediction equation for the estimation of acceleration, okay, or velocity. If it is the intensity, there is a intensity predictive equation. If it is the duration, is the duration predictive equation. So, the ground motion prediction equation generally gives for the SA at 0 or PGA to the SA at a different period, depends upon the equation when they develop. So, these are all the parameters are useful for the your prediction of the future hazard values. We have seen that the ground motion prediction equation or predictive equations varies a different parameters, so starting from areas, intensity, cumulatives and all. I told you to refer Douglas 2019 report for the global summary. Okay, in that the major equation we will be interested on the intensity predictive equation, and then the peak ground velocity, okay, and then acceleration predictive equation, and then duration predictive equation. These are all the things were routinely used in the seismic hazard analysis. Okay. Let us see what are the predictive equation we have. Okay, so as I told you that the number of predictive equation developed in India is much smaller than the number of earthquake occurred. Okay, so even a great earthquakes, you can say that a number of great earthquakes. For example, the number of great earthquake, we have seen that it was close to 11-12 earthquake, which has caused extensive intensity damage olden days before 1950, where there is no earthquake measurements are there. But if you look at the intensity predictive equation in the country, right now we have only one equation valid for the entire country. Okay. So, intensity predictive equations are called as a IPE, which gives the is the function of M and R, you will get a intensity value for any region, depends upon the past earthquake where they developed. It plays a very crucial role in hazard and risk estimation. Risk means like how much the damage you can expect, okay, how much intensity scale, because the intensity scale describe a damage. If you know the damage, you can estimate how many fatality can happen, how much economical loss happen. So, the micro intensity often used to record response of the earthquake in the past, provide understanding of the behavior of earthquake prior to the instrumentation. So, despite of being it is a qualitative data, uncertain assignment, the susceptible so other biases find fair use in the hazard evaluation, since there is a instrumental data is lacks in the many of the country, one of them in even India. If we have seen that many of the greater earthquake, we do not have the record. Okay, if you do not have the instrumented record, obviously you should go for the olden way of quantifying the earthquake intensity and then convert that into the PGA, or you can use it as such to predict your what is the loss. Okay. It is a large data available and easily interpreted out of own weight. Okay. Its limits, rabbit loss estimation model like prompt assessment of the global earthquake response, earthquake loss estimation. Okay. So, routine LER, and then the earthquake loss assessment and response and mitigation. So, these are all the some of the world level programs, okay, where they assess what is the economical loss, okay, what is the financial loss, how much the people will die. So, those kind of models highly depends upon the intensity predictive equation. So, the intensity prediction equations are so equally important, particularly if you want to assess a risk and loss for any particular region, because the PGA will give you the only the PGA distribution, but how the failure pattern, that can be obtained only from the isosysmal based model. So, these models consider population distribution, building fragility, shake map reflecting the attenuation trend over a region, thereby providing a quick alert during the earthquake to enforce government decision, prioritize recognize region and mobilize the rescue team. So, basically it helps on the disaster management planning. Okay, the disaster planning and management. Okay. So, even I read a news that we have been talking about the micro tremors in Delhi and other region. The NDMA approached Ministry of Earth Science asking them, can we need to do anything for this? Can we be prepared for the handling any big earthquake in the region? So, that is what they approach. So, such kind of the preparedness, okay, the planning will need to know what is the kind of loss you expect for the projected magnitude. So, that reason the intensity equations are the very highly useful one. So, as I told you that India, there was only one equation which is developed by the Zelika et al. So, this is the equation where he has given. So, he provided basically the Himalayan region different coefficient, Cretan region different coefficient, all over India different coefficients. If you want to go know about the more about this Zelika equation, please go through this. This equation also developed 2010. Okay, there was after that considerably there are few earthquakes are occurred, isosysmal maps also been available. This need to be modified or updated. Okay, that is we are actually working on that, some of my students. Hopefully, we can also come up with the new intensity equation for the southern India and north India soon. So, the equation basically considers a 12 events, okay, the Himalayan region and reported predicted using the EMS intensity scale. Okay, the coefficient of Himalaya regions are given here. Martin and Zelika catalog list based on the original source material archived in India and European libraries, regional newspapers, private letters and government reports. So, these are all the information they compiled and used to assign a intensity at a different distance and then magnitude from the past earthquake observation and try to get this regression equation, which is called as a intensity predictive equation, which will be useful to predict intensity for the any future earthquake. So, the prediction of equation, okay, GMPs, okay, is the next one. So, the predictive equation ground motion model. So, this GMPs are is basically the function of your acceleration or velocity. Acceleration means again the peak ground acceleration or SA. Okay. So, those kind of equation, predictive equations called as a ground motion prediction equation, because you directly know what is the motion amplitude. Okay, that is why the ground motion. So, this is plays a very important role on deciding the your hazard at a particular calculation. So, the accuracy of this kind of developed equations are very important. Okay. And not only the accuracy, you should also see that what is the data they consider. So, for example, as we know that the seismotectonic of the region influence what is the magnitude there occur, what is the depth it is occurring, how much the time acceleration plot look like, how the duration is. So, if you develop for example, the east part of India where the geological seismotectonic setting cannot be used in the west part of the India, even though the India is remains same. So, you have to select this kind of GMPs depends upon the seismotectonic details of the region by matching the seismotectonic details. For example, the peninsular India considered as a stable continent region can be matched with the similar stable continent region in the world. For example, east so northeastern America is a stable continent region. So, many earthquake data recorded or the understanding happened in the peninsular India has been used in the northeastern part of the US to predict hazard and understanding the earthquake effect. Okay. So, even the Bhuj earthquake, they have taken a very big lesson from the Bhuj earthquake and tried to they design for their buildings on that one, but still our side we forget after Bhuj earthquake most of the things. So, we have to keep moving same way what we are doing, which has to be corrected at least in the future generation. So, in India, so as I told you that the GMP was not well developed very olden time. The first GMP was developed in the actually 1996 by the Singh et al. Then afterwards again 2005, so then 2006, 9, 6, 10, 13, 14, 19, 19. You can see the gap. Okay, there is a huge gap period between that. This is the short form of the equation which I will be refer next time. So, the equations are at least started doing, but still the number of equation available for the entire India is less than the number of disastrous earthquake in the country. Okay, that I want to emphasize. So, you can see here the short form of the equation we have given. So, you can see the magnitude of range valid and the distance it is valid. And this is a general equation they used, but you can refer the original paper and the constant respective constant for the T equation. You can also see that, okay, so you can see the magnitude range. So, one has to be careful about that particular magnitude which is applicable or not. Okay. And then they also given a equation form like site class, rock, okay, all those parameters you have to carefully go through and try to understand and know your applicability and then identify that equation suitable to you or not. Okay. So, this anyway we will be discussing in the next class the selection of the GMPs. So, further we will discuss on this. You can see the equation, you can see this. So, the NDMA will be the most robust one where the gap between the the magnitude range is very wider, but there also some issues there because this was completely synthetic data. Okay, as I told you that NDMA is completely synthetic data. So, rest of the data is actually consider the recorded earthquake, but it has only a short distance it valid. Okay, you can see 100, most of them are 100 km except Das et al, but the Das et al magnitude of this range is very small. Okay, it's a 5.5 to 7.2. Okay. So, similarly, so then we actually try to overcome that. Okay, so by adapting a more data and considering more distance by combining synthetic and ground motion data, that again further we modified. So, this is basically for the Himalayan region. Okay, so you can see 4 to 9 we developed and this with 10 to 750 km. So, then the Kumar has developed this one with this much distance. So, as and now this is the equation which can be used widely for all the range of distance. Okay, let us see how this equation surfaces in the your LLH approach like selection procedures. So, similarly peninsular India we have about 7 equation, out of 7 2 was developed by us, 2 was developed by the Bhabha Atomic Research because Center. They have their own equation because they are the one who basically do the detailed seismic hazard analysis for the nuclear power plant, particularly the Tarapur, Vizag, okay, the Kudangulam and then the Chennai. So, these are all the major plants in the South India. So, that is why they developed their own equation. Since I was expert member in those committees, okay, these equations also reviewed by me and assessed by me. Then NDMA, they generated for entire India in 2010. So Raghukant and Iyengar equation was the first equation in the peninsular India, where it was developed in 2004, okay, by considering the Koina earthquake and other thing. So this is the basically, if you narrow down this one, it actually we have about only 3 equation. Why? Because the equation 1 to 3 is done by the same group of researcher. This is done by the same group. Okay, this is the 2, this is the 1, and this is the 3. Only 3 people worked on this and developed equation, which needs to be enhanced, because after 1950 we have seen that number of earthquake, damaging earthquake in India is close to 5. Okay, but still we have the only 3 GMPs developed by the 3 groups. Okay, with the different this one. So this is the typical equation where you can see the range of magnitude, it is applicable, you can see. Okay, so then the RDS one you can see. So here also, as on now, I can say that this is the wider range of distribution and magnitude applicable GMPs, okay, for the peninsular India. So GMPs for the northeast India. So basically northeast India, as I told you, that is a complex. So you cannot use the GMPs north as well as southern India. So they have their own equations. Some of them which is applicable in the northern India also may applicable to the northeast, as they use here composite data, but still the applicability has to be validated. But still the author claimed that it is applicable to both. That's why it has been listed here. You can see the 99 Singh et al, Sharma, the Singh et al 2016, Nath 2012, Nath et al 2005, Das et al. Okay, so the range, magnitude and distance range. Again Sharma and Burgham et al, Boro, Nath, Sharma et al. Okay, so that range you can see some of them he were given very small magnitude of range. I am not very sure what kind of application you can use these GMPs. So similarly, this is for this one. Then this is a Bajaj et al, what our equation which is very recently done, considering the both north and northeastern part of data. You can see the respective equation and coefficients. As I told you that all this equation, if you want to use, you should not take it from this class video. You should take a respective paper and check everything and use it. Okay. So these predictive equations are useful to estimate a peak ground acceleration, peak ground velocity and peak ground displacement, and also a acceleration time history, like you will get your response spectrum parameters. Those are all the GMPs are there. So the another important parameter, okay, so apart from the intensity and then the PGA or PGV, there is another parameter like duration. We have seen that durations also plays a very important role in the damage of the structures. The cumulative damage experienced by the building not only depends upon the spectral acceleration or peak ground acceleration, it is also depends upon the how the prolonged duration taking into picture. So the structural response during the strong earthquake depends upon the duration of this one. So the predicting duration also very important. There should be need for duration predictive equation for the any region. So we have seen that Douglas summarized so many predictive equation. As per India concern, the predictive equations are very limited. There is no predictive equation at all. There is only one equation which was developed by my research team, but that is also for the intraplate region, not for India. We used India data. Okay. So basically southern India, we collected different data from the intraplate regions, particularly where the Baba Atomic Center, they used some of the intraplate GMPs. Those data has been shared. So and then we have used that, and then we come up with the new equation considering the Australia and then the other intraplate world region data from the BRC and the Indian data from ourselves. So this is the paper you can refer for this GMPs, you can see. So this paper gives the ground motion prediction equation for the duration. Okay, yeah, predictive equation for the duration. So this is applicable to this range and distance of this range. Okay, this is the first equation for the prediction of duration of the intraplate earthquake. So this is published in this one. So we basically estimated the bracketed duration. This is the function we have used. So then again we done for the significant durations 5 to 75, 5 to 85. This is the function we use. So if you want to get the coefficients and other details, you can check this table which is given in the paper. So you can also go through. So this we have defined here basically different duration, significant and bracketed type of durations, and we have given this equation where people can use m and r as a function and to get the your this one. We also consider rock site and soil site. Okay, that means rock site you will have the different duration, soil site will have the different duration, your m and r may be the same. Okay, that message you should take it from here. So, these equations are useful to predict duration if you are interested for the liquefaction, slope stability and anything structural damage related studies, you need this kind of equations. So, these equations are very important role, okay, in the hazard analysis, because the hazard analysis basically you are estimating how much the peak ground acceleration we are going to expect, how much intensity you are going to expect, how much the spectral acceleration at different period we are going to expect, how much the duration we are going to expect. So, to estimate that you need a this kind of predictive equations. This is also called as a attenuation relation. Okay, so the generally ground motion prediction equations, something like that. Okay, so all those things mean a same. There is a predictive regressed equations which is the function of m and r and then the soil type and source model. So, generally source soil type they use for large number of data accurately available, otherwise m and r is generally used. Okay. So, these equations, as I told you, there are so many equations in India itself. If you look at a global scale, you will have much more. So, how these equations should be systematically selected for any particular region. Okay. So, generally for the normal people who do the hazard analysis without knowing the detailed knowledge about the understanding of seismotectonic and then the seismicity in the each region, they select randomly any equation or they use based on their own knowledge on the GMPs and then do a hazard analysis. That how you will get affected by that, how the hazard values will affect, that also we are going to discuss part of our course. So, we will discuss a selection of GMPs, why it is important in the next class. Thank you very much for watching this video. So, I will meet you in the next class. Thank you.